Welcome back to Leetcode Day 10. Today's problem, we're doing search in a rotated sorted array. There's an integer num sorted in ascending order with distinct values. Prior to being passed to a function, nums is possibly rotated at an unknown pivot index. Blah, blah, blah. Given the array nums after possible rotation and an integer target, return the index of target if it's in nums or -1 if it's not. And it has to be log n time complexity. Now this problem is binary search, but it's annoying in the fact that it's rotated. So let's say the intuition is kind of, we're gonna write a basic binary search. So let's do red. So let's say the middle of 7. We should check what left is. If left is less than mid, then we know we're in the left side of the array. We want to split the array into like 2 parts, because most of the time it's like this side or it's the right side sorted. So you call this left sorted and this is the right sorted. Since our target is 0, right? We know we first check mid, since it's less than target. Obviously, normally we would go here, right? But we also need to check what this value is. And since 4 is greater than 0, we actually want to do left equals mid plus 1. Because remember, if we want to think about this, it's still sorted, but it's rotated. If the lowest value on the left, which is this index here, oops, let me go back. I accidentally clicked the button. The lowest value is already greater than the target. That means we can just cancel out all these values. We don't need to check here, and we instead want to check here. And in the same way, if we start in the rightmost, we want to check. Let me remove all this first. We want to check. Let's say we're like around here. Oh, we want to check the left. Left is greater than mid, right? Let's pretend this is mid. 1 is mid. Left is greater than mid. So we probably don't want to check all of here. Most of here. We want to check the right side. So, okay. Okay, for the right side, let me reiterate, because I think it was a little confusing before. If we start here, that's greater than the target. So usually we do, and in this scenario, we know that the leftmost number is greater than. That's how we know it's in the right side. Basically, how we know if it's in the left or right side is the left less than mid, or is it greater than mid? Since left is greater than mid, we're gonna do a different approach. We're gonna look at the right. We're gonna assume like most of these numbers here are probably gonna be not the target value. Or we kind of want to do a different approach. We're gonna check, oh, is this less than? Is mid less than target? Is it? If it is, then we know we should also check the right. Remember how we were checking the left for the target? The value, so the value 2, it's greater than the target. Alright. If this is the greatest number, remember before we knew the leftmost numbers to use the lowest number in this like left sorted array, but now we're in the right sorted. We know the rightmost number is the greatest value. So we, in this scenario, we do right minus. Right equals mid minus 1 in this scenario. I hope that explains, but if you didn't get all that, I hope the code can explain. So I'm gonna do a simple binary search. Right, doing -1, -1, less, then we go to right. If mid equals, you can just do left plus right over 2. Now this is the first part. If left nums left is less than equal to right. Not right. It should be nums mid. So now we know we're in the left, our mid is in the left portion of the array. We're gonna do if. Also first we should probably do if nums mid is equal to target, which should just return mid. Okay. So let's say in this scenario 7. Okay, which 7 if nums mid is less than target, or nums left less than target. Is that how you write it? Okay, let's think about it. Nums mid less than target. Mid. So our target 0. So is 7 less than target? And nums left, if it's greater than target, we should do left equals mid plus 1. And else right equals mid minus 1. You see, in this scenario, like we see that 4 is already greater than 0. That means we can just cancel out all these, essentially. And we know because we're in the left sort of right. That's it for that. And then let's do right. If we're in the right sort of right, let's say we're at 1. If nums mid less than target, mid is less than target, or nums. Now we're checking the right. If it's greater than target, let's say less. I think it should be less. If I'm right. If it's greater than target. If it's greater than the target, which this scenario is, then we probably do right equals mid minus 1, and then else like left equals mid plus 1. Mid is less than the target. Mid is less than the target. If mid is less than the target, scenario is greater. Should probably be like here. Hopefully this works, unless I did something wrong. Unless I forgot to return 1. Oof. Case 4 I did wrong. Okay. Let's see. So if I submit, I probably did something wrong in the implementation. Okay, we passed most of it. So I think I wrote the top right, but this is probably wrong. So let's just see if nums. Alright, I'm back. This should be less than. This should be greater than. Because the rightmost value is already. If it's less than the target, we know it probably spilled over, so it's like in this area. That's why it should be less than, and then it should just be greater than. Like typical binary search, and then yep, that's it. Thanks for watching. I'll see you guys in the next one.